Welcome to Technical Session 4C. Good morning, good afternoon, and good evening. It is my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time, and we all will together pass this soon. We hope you will enjoy last day of the knowledgeable and interactive sessions. Just before we get started, I would like to introduce you all to the chair of this session, Dr. Vivek Tiwari. Dr. Tiwari is an assistant professor of computer science and engineering at International Institute of Information Technology, Naya Raipur. Research interests he includes data mining and warehousing, pattern mining and warehousing, data analysis, pattern retrieval and presentation, machine learning, and big data. Over to you, Dr. Tiwari.
Thank you. Thank you for a brief introduction. And I also welcome to all the participants, whether they are researcher, professionals, academician, and students. It always be a great moment to prepare a paper, search for conference, and it's always be feel very proud when we have a chance to present our paper to the community so that we can share our findings, our learning, our experience with the other. And moreover, when you go for the session, like we have a session, and most of the time sessions are like that, the common paper and similar type of papers are kept together to having a better depth discussion. So it's opportunity for me, for other also to listen, to learn from other works. So I think so. This platform will give you opportunity to everybody in this pandemic time to move ahead, to learn, and to enjoy. So best of luck to everybody. Great congratulations to having a paper in such a reputed conference. Apart from that, dear Amanji, Madam, and Amit Joshi, all are my friends. They are conducting a lot of good conferences, having a very tough fight to selection in such kind of conferences. And big thanks and big congratulations to them also to keep on working in such environment. So in this word, I will not take much time and will request to coordinator to open the session so that people may start their presentation. Thank you.
Sure, sir. Thank you so much, sir. Now, I would like to start with the papers. Our first presentation is from Mr. Sanjeev Manchanda. His paper is about Artificial Intelligence Driven Monitoring, Prediction and Recommendation System, AIM Prism. Hello, Mr. Sanjeev.
Yeah. Hello, everyone. Yeah, Sanjeev.
Dr. Sanjeev, welcome, and I request to other participants also, please adhere the timeline suggested by the conference organizer. We have a limited time, so I think time is given to 10 minutes around that. Please try to focus on your core finding, your experiment results, your conclusion. So you can pace your presentation based on this constraint. Thank you.
Yeah, thanks, Dr. Tiwari. So I hope my presentation is visible to everyone.
Yes, go ahead.
Okay, yeah, thank you. So I will quickly just take through the agenda. So I will talk about what kind of problem we have picked up and how the system is being developed. And later on with the results, I'll be presenting. So for limited time, this PPT is already available with everybody. So Honorable Chair and everybody, good morning, good afternoon, good evening, everyone. So the problem definition that is being picked up. So I worked with TCS. So in TCS, there is an agenda to create the custom solutions for the our customers. The main idea is we are the service-based company, but with that, The product creation is also, and the accelerators creation is one of the key area, and we are working on that. So this problem is about there are so many applications in the enterprise organizations. So how we can help all those organizations in maintaining all those applications. So AIML nowadays, it's a big trend, and it's a time when the difficult problems, those were not able to be catered earlier, AIML is enabling them. So for the monitoring, prediction, and recommending what kind of problems are happening in the enterprise level solutions or applications, how we can help the organization to maintain their system. So this system will monitor, maintain the applications, and it will use latest technologies like edge computing, AIML, to do some kind of action-driven insights. So that's what the focus will be. The limitation, earlier solutions were having lack of the automation, and the kind of problems those were there, those were not able to cater that one. But nowadays, AIML has enabled many things. So this solution has come up. So this solution that has come from the artificial intelligence driven monitoring, prediction, and recommendation system. So this is the system, that is the AIM Prism is the one fancy name, taken few characters from the this complete sentence is being taken, and then this is being formed. So it will take the AIML and edge computing as the prominent technologies to help the organizations to centrally control the system, even when the decisions or the implementations are available in the distributed manner. So we will see how it happens. So here we can see that the architecture of there are a large number of applications that the different organizations are having. Then there is a central repository that takes the input in real time as well as in the uh, batch mode, and then processes that whole data. So there is one storage and intelligence server. It does the AIML processing. Not only the AIML processing is available at the server side, but also as the application side as well. So edge computing enables some few of the processes can be executed on sources directly. And there is one administrative module, and then the visualization and alerts, those are getting generated. So based upon that, doing that one. So here is the real core process flow, where the applications are being sending the real-time data, real-time analytics is happening, and the real-time controls are taking place in the system. And the alerts or the visualization is being generated, maybe the real-time alerts as well as the uh, long-term reports, and all kind of combinations are available. If we look at the overall process, so what is being done here, you can see that the data is getting passed for the batch processing as well as for the real time. So real time is monetizing the, or it is the using the edge computing, where the real time execution of few of the processes take place at the application side itself, whereas few of the processes come to the uh, edge gateway, and rest of the things are being done on the background at the repository side, where the AIML plays an important role. I will come up with few examples as well. So this is a topology to maintain the high availability, that the different applications are connected with the different kind of servers, and then centrally that is being maintained. If any of the server goes down, but topology will ensure high availability of all the applications as well as the data available. So if we look at the example side, real-time analytics, if we look at the real-time analytics, for example, if an application server is getting overheated, so it will take time to generate alert, and then human being will do some kind of, take some action. So system automatically will cut off the system, or it will shut it down so that it will not catch fire. So this is a real time. It will happen at the edge device itself. Then the near real time example we can take at the edge gateway side, where the nodes are being taking the actions when the some of the server or the application is not responding. Long term reporting or the central repository based reporting, that is an ongoing activity. AIML will help into that. So all type of analytical example, the actions are being involved at the device side, edge gateway side at the server side. So this is how, and this is the algorithm that is being discussed here. When we devised this system and compared with our benchmark, so we were overwhelmed with the results. The results may have a little bit variations because the kind of problems maybe the benchmark was having, that may be different. The kind of issues we uh, uh, got, that may be quite different. But if we see at the result, the problems earlier were 63%, now it has reduced to 22%. So all the stats, and we were able to identify 91% issues. So all when our benchmark that we had taken, when we use the system, the overwhelming results have come. But now we are trying this system on more and more systems so that we can generalize the results and give the better stats. But this is the result based upon our benchmarks. The problems those are being identified in the systems, those may be different. Then we have the advantages. It is a centralized control. It is an automated system. Reduction in effort that is being observed. Ease of use. The UI is quite very good, very user friendly, and performance and reliability already presented with results. And the key differentiator of this system is the use of edge computing as well as AI/ML. Then the implementation over there. So currently the system is being implemented and we are collecting the users feedback, and we are planning the future releases of the project. So this is a more about the customized system implementation. So to honor the time, I'm just
Yeah,
closing
thank
that
you,
now.
thank you, doctor. Thank you, doctor. It nicely you have explained within a time. So,
Thanks.
so the architecture point of view, the application is very on demand in the market. So the pre-processing that you have done normally it is, I think, live video or streamed video.
Uh, Actually, the sorry, can you come up again, Dr. Tiwari? So I missed
Yeah,
your.
yeah. My question is that sometime we have a streamed video somewhere store, and we are allowed to do a processing. Sometime the live video are there coming, and we have to do the processing. So what kind of processing you are proposing?
Actually, this application live streaming of the data means if some application is running on the in enterprise, you understand that thousands, hundreds of applications are running. They are doing their processing. Are those are what is the health of those applications? Are those running fine? If there is a problem over there, for example, the server is getting heated, so rather than we go and turn off the system, this system will automatically trigger a command. So right now
Okay,
we
that's
are
okay.
just
That, yeah, that is the objective. So my confusion is that what kind of data, that is only image, video, text, unstructured, unstructured. What kind of
yeah,
data you are?
yeah, this is unstructured, semi-structured and unstructured data that we are collecting. So whatever the packets, as well as for example, there are certain logs. The systems are generating. We are collecting those logs and real-time streaming of the what processing they are doing.
So
That
suppose we have
processing.
a very good. Suppose we have a data like in a log format. So how, which tool you have applied to work with the log and structured data, like Python or any other dedicated tool if you have,
So
then please.
this is a Hadoop based that the
Okay. Hmm.
Spark engine has been ingested. That is bringing up the real time data, and there is a batch processing that is also happening. Whatever the old logs are there or other data is available at the applications, because different applications have different kind of configurations. So
Very good.
whatever
Very good.
data is available, we bring that up in the batch mode as well as the real processing mode.
Very good work. Very, I
Possibly.
appreciate it, sir. Very, very good
And
work. You should
structured data is
continue.
there. Structured data is also brought with the SQL based.
Yeah, yeah, yeah. You should continue and try to work and install in the real environment. I think that will
Yes,
be good for
yes.
you.
So
So
that is what the
impressive work.
objective. Yeah. Helping the
Thank you.
customers to solve their.
Thank you.
Thank
Thank you
you
from
so
my
much,
side.
Dr. Tiwari, and thanks everyone for listening. Have a nice day. Thank you.
Thank you so much, Dr. Sanjeev. Our next presentation is from Mr. Akash Vijayan. The paper is about data center stimulation for resource utilization analysis at extended loads.
Good day, everyone. Am I visible and audible?
Yes.
Yes, thank you. Sure, just a second. I'm sharing the screen. Okay, is the screen visible?
Yeah, please go ahead.
Okay, so good day to one and all. So before we start, I would like to thank the World S4 conference for giving us such a wonderful opportunity to present our paper titled Data Center Simulation for Resource Utilization Analysis at Extended Loads. The paper ID is 375. And me myself, I am Akash Vijayan, presenter and co-author of the paper. The fellow authors are Matthew Koshi scientist, Dr. Ansama John, and Manu J. Pillai. So the overview of the presentation is we have an introduction, then we say about the data centers, then we discuss the various causes for cloud outages, then our simulation methodology, and finally the conclusion. So without wasting our time, we can go into the introduction. So basically for the past few years, the usage of internet have been tremendous, and there are a large number of services which are migrating towards an online kind of thing. And the online app services are actually managed by different applications, programs running in the server, which are located around the globe. So they run 24 into 7 to ensure it's available and accessible by any internet enabled devices around the globe. So they are available to us anywhere and anytime, but still there are cases where the online applications or online services go down, and the factors that causes these are many. And one of the main reason is that application, when they are developed and tested, they are tested for bugs, business logic, etc. But they cannot create an environment where it environment similar to a production server. Like there are a lot of users using the application at the same time, the load comes and goes, the number of requests is changing. So such a scenario is not being able to make in a development and testing phase. So in order to get an idea about how the application works in such a condition, we propose a simulation environment where we simulate the working of a data center, so that we can get the actually the resource requirements of the application in various scenarios at various loads, various times, etc. So data centers are actually centralized facilities consisting of large number of computing devices and their service requests from devices across the globe, and it runs 24 into 7. And applications are actually applications we can a single application can be served across multiple instances according to the load, etc. And for the particular case of Amazon Web Services, they provide server configuration which are optimized for memory, computing power, storage, or as a general purpose instances, which is on an average optimized for all of these, that is memory, computing power, and storage. And they provide a minimum configuration. The Amazon EC2 instance provide a minimum configuration of 1 CPU, 1 GB of memory, and no storage, with a maximum and up to a maximum configuration of 96 CPU cores with 384 GB memory, SSD, 100 GB network bandwidth, and 256 GB of graphic processing unit. And so which says that a physical data center is a collection of large number of different varieties of physical computing devices. And basically, talking about the cloud failures or cloud outages, it says that half of the cloud services across the globe experience an outage of on an average, it experience about 3 outages a year, which is excluding the regular maintenance works, etc. So we can divide that. It's classified into four. Hardware, the causes are classified into four: the hardware failures, software errors, human errors, and unmanageable load. And hardware failures can be anything like an issue with a network switch, etc. And software errors can be bugs in the application,
Yeah,
or
dear Akash, I request to just discuss your contribution and finding. It is
yeah,
a
sure.
fundamental introductory part. You can skip it.
Okay, so these are the courses, and then we are moving. We'll talk about the methodology where we are trying to propose a simulation tool, and basically it's consisting. From a fundamental point of view, it executes process instances, and actually we list applications which are collection of processes or process instances, and these process instances use up basic system resources like memory, CPU, disk IO, and network bandwidth. And also this application have seasonality components, that is the change variation in the number of requests coming onto the server at different times, and then load balancing components which actually increase the number of application instances and decrease them according to the load on the server. And also finally, ultimately, they produce the resource utilization metrics of the applications that are simulated. So this is the architecture of the simulation tool that we propose. It has a configuration where we define the system, the this resources available for each of the instance, and then we can configure the applications. And then data is fetched from the system config by the initiator, who reads out the system configuration to find out the number of application, which is led into a load balancer. Load balancer, for each of the application, there is a load balancer which defines, which creates instances for application, that for a single application there can be many instances according to the load, and each of those application is simulated separately and or is separately by a simulator module accompanied with the system resource module. And the system resource simulator module takes care of the simulation, and the system resources module takes care of the allocation and reallocation of the different resources. And then at regular intervals, the resource utilization metrics are generated. And after the simulation, we have an output file, which is actually a resource utilization metrics, which is then visualized using some visualization tools. And talking about the configuration, we have system and application configuration. And system configuration defines the system resource availability, quantum for the CPU scheduling, simulation duration, interval, etc. And the application configuration is where we define the processes, the different resource requirements for each of the processes that we model. Then the seasonality of the application, then dependency, that is inter-process or inter-resource dependency. Then we have load balancing policies. And then the initiator reads the system configuration, generates the load balancer objects for each of these application, and then it starts the simulation for each of the application instances, and then finally produces system resource utilization metrics, which is finally pushed into some time series based database at the end of the simulation. We have the load balancer module, which reads the application's configuration, generates the application and corresponding application processes, and creates the simulation and system resource. It handles the simulation and system resource modules for each of the application or server instance. And it also scales up or scales down the application according to the load, also distributes the incoming request to the different instances of the application. Then we have a module then we have the application instance, which generates the processes and process instances. That is, it's actually generate a ready queue type of thing. And then the number of processes at any time is dependent on the seasonality and the time. We have the simulator, which actually takes the generated process instances and simulates the execution of the process instances in that, and it simultaneously communicate with the system resource module to allocate and deallocate system resources. And the system resource module and the metrics generated together keeps track of the system clock, as well as creates the system resource utilization metrics at every intervals. So that's the final output. And at the end of the simulation, we can actually, the simulation can be done for weeks, days, weeks, or even months, and we can configure the entire characteristics of the application throughout that period and get the output for overall output for the whole simulation period. So finally, we have the resource utilization metrics generated at the end of the simulation, which is visualized using some visualization tool like Grafana, and which shows us the graphical representation of each of the applications instances resource utilization at every moment. So finally, we have a talking about the conclusion.
Yes, dear Akash, just I want to know, simulation results. You're talking about you have some matrix. So by matrix, you can understand whether your policy and your innovation is really fulfilling your requirement or not. So what are those parameters by which you can evaluate your policies?
Actually, the simulation is basically dependent on each of the processes resource requirements, and then when the whole of the processes are together simulated, so the number of processes, that is the traffic or the load on the system, is also a major factor depending on the final output metrics. And also For
Yeah, these are the input. Okay, these are the inputs. What are the output of results? Means how could you like a simple? You can say the if the CGPA is high means you are very good in student, or accuracy is high means is a better model. So what are those parameters?
So, sir, for initially before the simulation, we have the configuration. So, in if we say that we expect such a traffic or a particular amount of load for the coming few days, then we can simulate our application for such condition, and we can get the resource requirement of that of the application for that period. So that is once when we deploy an application into the AWS instance, we only allocate them a certain amount of system resources for their smooth running. And in case we are expecting a particular a huge increase in load in the next few days or next months, then we can simulate them in order to find out how much of extra resources will be needed by the application during that period.
Okay, thank you from you. Try to just do experiment with the real environment if possible you have.
Yes,
Otherwise, very good work. Go ahead. Thank you.
thank you, sir.
Thank you so much. Our next presentation is from Ms. Surya Begum. The paper is about a detailed study for bankruptcy prediction by machine learning technique. Hello, Ms. Surya.
Yeah, good afternoon to everyone. I hope I'm audible.
Yes, you are.
Yeah. One second, I'm just, I have already shared the screen. I hope it is visible.
Yes, ma'am. You can make it slideshow.
Yeah, please go ahead.
Yeah. So, can you see my slide, sir?
Yes, go ahead. Start, please.
Okay, sir. Okay, thank you. Good afternoon to everyone once again. So today I'm going to myself, Dr. Suraya Begum. I'm going to present a study on the prediction of whether a organization or company will go into bankruptcy in the future by using the machine learning techniques. So this is my personal details, and this is a overview of today's presentation schedule. Abstract, then I'll be telling about the objectives, followed by a brief introduction and the different works done by the different researchers, that is in the form of the background work. Then the methodology used, followed by few visualization. Then how we have done the feature engineering, that is a selection of the features. Then what are the algorithms we have used for our study. Then finally, I am going to show the results. Then I will conclude the session with the future work and references. So this is the abstract. Like just because of due to like we are having like a few minutes to tell, just I would like to tell about this in 1 minute. That is the problem here is we have to we have to predict whether a organization or a company will go into bankruptcy in the future or not by using the different machine learning algorithms. So here I have taken the data from Taiwan Economic Journal for a period of 10 years, that is from 1990 to 2009. And it has 6,819 records with 96 features. This is the original data. So in my paper, I have used 4 algorithms, that is random forest classifier, XGBoost classifier, then logistic regression and artificial neural network. And also I have used the technique that is the k-folding with the k value as 10 that I'm going to show in the slides after a few minutes. So from our results, I have found out that random forest classifier outperforms when compared to the other 3 algorithms with a accuracy of 96.53%. The second highest accuracy I got in artificial neural network with 96.12%. So this is a brief introduction about the abstract. Now coming to the objective, here the main objective or goal is to, like as already I have mentioned, to predict whether a bank, sorry, whether a organization or any company will go into bankruptcy or not. So since it will fall under classification problem, we will be having 0 or 1, that is true or false. So 1 means the bank will go to bankruptcy in the future. 0 means it is not going to be bankrupt. So this is what my goal is in the study. So this is a brief introduction about the bankruptcy, because as already sir told that without going to introduction and all, so I would like to show my work, if with your kind permission. So
Please,
this is
please,
the
please discuss your results and contribution.
yeah, sir. Thank you so much, sir, Vivek sir. So this is the background of all the other researchers which they have done. And here, sir, one point I want to stress upon is like when I have done this research with the different researchers, I found only this 92%. Okay, by the Pragya Patel, she has proposed a new model by using the naive-based classifier, and she has got a accuracy of 92%. So this is what I just wanted to tell, because when compared to our models are performing better. That I'm going to show you in the future slides. Now coming to the data set, okay, we are having two types of features here, numerical as well as the categorical. Then we have to encode the categorical variables. So there are two main important techniques. That is, one is label encoding, the other one is one-hot encoding. In my work, I have used label encoding. Then the various techniques which I have used. Okay, there are so many techniques for the selection of the features. So the following are some of the important techniques using which I have selected the features for my model. So one is the correlation, then the feature importance, missing values, and the domain knowledge. So these are the various techniques. When I say domain knowledge, I have collected some information about the articles, blogs also, research papers, and also I have talked to some experts to get the clarity, and how and all these things. Based on that also I have taken some of the features, apart from the other techniques for the feature selection. And then the techniques, various techniques I have used for dropping of the features is correlation. That is, the variables which are highly correlated will be dropped. Then based on many features, we are going to select one feature. Again, that depends upon the independent and the dependent variables and their contribution. Then coming to the next technique is feature importance. If no feature, again this depends upon the contribution of the various independent features. If they don't have any contribution, that is a 0% contribution, we are dropping that particular feature. So likewise, the missing values. If the missing values are greater or equal to 60%, then that particular feature we are not taking into consideration for our study. And then, as I have already told you, virginal data set, we had 96 features. Okay. After all this feature selection technique, that is correlation, feature importance, and treating the missing values, dropping the duplicates and all these things. Finally, we have taken 22 features in my model. Then coming to methodology, as already I have told you, it falls under the classification problem category, I mean. So we have used multiple multiplication classification models to perform our study. And also we have tuned the hyper parameters to get the maximum accuracy. So this is the heat map, that is the visualization of the 22 features which I have taken for my study, which will show the different contribution and the relationship between the independent as well as the target variable, that is the bankrupt or not. Then as already I have discussed about the feature engineering, by using the different techniques, I have taken the features for my study. And here the k-fold value I have taken as 10 because I tested with different values. So when it was 5, it was the accuracy was little bit decreased. So then I have used the next value as 10, which gave me the accuracy a little higher when compared to the value of 5. So this is the count of the target variable, that is the bankrupt. It is showing for non-bankruptcy and bankruptcy also in the figure. So here, as already I have told you in the objective, 1 means it is going to be a, it is going to predict as a bankruptcy. 0 means it is not bankrupt. Then algorithms. These are the four models which I have used: random forest classifier, XGBoost, logistic classifier, as well as the artificial neural network. Then coming to the metrics evaluation, that is the result. As already I have mentioned in the starting, random forest and artificial neural network outperforms when compared to other two methods, that is the logistic regression and XGBoost. So this table shows the different precision recall values along with the F1 score. So from this result, we can see that this random forest as well as this.
Sorry to interrupt, ma'am. You have last 1 minute, please.
Okay, sir. Okay, sir. So, okay. Sir, accuracy, like as already I mentioned that random forest and artificial neural network, like a slight difference after the decimal points we are having. Random forest, I'm having 96.5, well as artificial neural network also a slight difference, that is I am getting 0.12% in the case of artificial neural network, then followed by XGBoost and the logistic regression. Then coming to the confusion matrix. So this is the confusion matrix, okay, of the four already mentioned the models which I have taken. Then this is the conclusion part. So in the conclusion part, like whatever I have discussed, that I have mentioned with the accuracies of random forest algorithm and artificial neural network when compared to other. That is what I have told that Pragya Patel, like by using naive based classifier, she has got 92. The maximum accuracy she got was 92%. So we got 96 point change.
Yeah, thank you. Thank you.
And 1 second, sir, before concluding, this is my future work. So what I am planning is, this time I have taken the Taiwan data set. Okay, next time I'm just planning to take a data set that is Indian data set, and I'm going to do the prediction. Yes. Sorry for
Yeah.
taking 1 or 2 minutes more, sir. Yeah.
Yeah. I have just two suggestions.
Yes, sir.
So when you have a data like you have used and set of algorithms you have chosen to apply on those data like ANN and random forest and XGBoost. So whatever the results you get, it's okay. But you must always mention if one or two algorithms are performing better than others, then why? That is actual real learning. A data having or calling the predefined function of the algorithm and observing the result is one phase. More critical and more important phase is that you should know why ANN performs better than XGBoost. That is most important part. That is most better learning, and it will make you happy really.
Yes, sir. Yes, sir.
So because randomly this time you have selected four algorithms, you might have a 20 more algorithms.
Yes,
Why
sir.
not?
Yes,
Why
sir.
you have selected? Somebody will ask why four algorithms you have selected.
Yes,
What
sir.
was the criteria?
Yeah, sir. I will just tell you. I have an answer for this because I have
Yeah.
tried with SVM also. That is the support vector machine,
Mm-hmm.
and the other techniques also. I
Mm-hmm.
have tried because the features for 96 I told you, I have tried with PCA also, that is a principal component analysis also. But
Mm-hmm.
coming to the accuracy, because finally we want our model to give the maximum accuracy, those models were not giving the accuracy, good accuracy. So that's why after that, after modeling by using those techniques also, I have chosen this because they were giving the accuracy,
Actually,
good accuracy.
accuracy is depend on many things
Yes, sir.
like a random forest. What kind of pruning you have used also does matter. So you also include this kind of pruning method I have chosen because you have a lot of options to prune your data. So it is an essential part of random forest. So sometime if I use the X technique for the pruning, it's the same random forest, and you are using Y techniques, the results drastically may be different. So these machine learning algorithms we should not consider as a single unit. A single algorithm having a lot of parameters, a lot of options that you can customize. So what value you have taken for the customization for the same algorithm, if I have taken different value, will have a different results. So in presentation, always include the parameter setting, which hyperparameter
Yeah,
value you have adopted.
yeah, sir. For this, on this point, I would like to answer you. Yeah, like rightly you said, like I have taken the number of estimators. Number of
Mm.
estimators I have taken as 400.
There are
Uh,
many,
yeah,
not
many.
yeah, many like pruning. Which kind of pruning you have adopted in random forest, like that? So
Okay, sir.
pruning is something that is drastically improve the result or discrete the result. By default, what pruning techniques were set in which tool you have used? Maybe Python, maybe.
Yeah, Python, sir.
So what was the default technique? So these all things matter. These are only suggestions, and
Yeah, sir.
at the beginning level, that's a good work. I should appreciate. Thank you.
Yeah. Thank you, sir. Thank you for your valuable suggestions.
Thank you so much, ma'am. Our next presentation is from Mr. Arvind Kumar. His paper is about a survey on learning-based gait recognition for human authentication. Hello, sir.
Hello.
Yes. Please start the presentation.
Okay. Now. Good afternoon, everyone. Good morning and good evening to all. My paper is on survey on learning-based gate recognition, human authentication in smart cities. Mm, we are going to cover in this slide is introduction, literature survey past, proposed work and performance evolution and data sets and performance dat- data sets used and performance metrics, results and discussion, conclusion and future scope references. These are the introduction part. We are going to introduce our topic. A smart city includes the good infrastructure, better transport, connectivity, and security. In this paper, we have presented a state of art on different machine learning techniques used for identification of human being authentication according to their movement. We presented a comparative study of such scheme and provide our major findings of the survey. Mm, Identification of the human being using a movement is the biometric technology where the pupil even farther away we can find out even their face is covered or hidden or even not visible to the camera in dark areas. So coming into the next, these are the overview. This in the high security chain area how the this gate mechanism can work. And these are the model by which we can implement the gate based model. That two method, the model based and the motion based. Based method we can mathematically compute it, and in the motion based method we have the sequence of images for extracting the feature from the images. And these are the application where this model can be implements in surveillance system and the security in smart cities and sports mainly, and the healthcare. So when we compared our techniques to the fingerprint identification and the other iris based identification technique, where we found that this gateways have uh, feature that they does not require user communication and can be done as long as distant gate can appear. These are the issues and challenges of our found we. So now we are saying that the cities are moving toward the smart era, so they required some efficient technique for enhancing the security in the smart cities. So coming into the motivation part, why we choose this topic, that what motivates us, as we are seeing the criminal investigation for the smart city is the challenge, so it required method which enhance the security in the cities. Coming on to the problem statement part, we here we design a gateways authentication system for providing the security and a smart city in the machine learning approach. And these are the literature survey that we have gone through. uh, these are the few papers. There's 16 paper we have gone through. After that, we have found out that the approaches which are using neural network and the supervised machine learning tech, so support vector machine are having a higher precision and the accuracy with compared to others. Uh, that we cover. After that, we have worked on later on. We have also discussed the mm, proposed work. That was that we first start that the and we have taken the human frames as an input, then pre-process them and reduce the feature by using the PCA, and then we extract the feature extract and the train the database, and we they recognize whether the by after testing we recognize whether the uh, system is able to find the person or not. If they find, we can say the person got authenticated, else the person not uh, authenticate. The procedure we are going to cover in this method, that the capture the image with the help of camera, pre-process the image is done, and extract the feature from the image, train that feature to the database, apply the classification technique for extracting the result. And this is the pre-processing where we have done three things, that the resizing the image, after that noise reduction and the segmentation. For noise reduction we use Gaussian blur function, and for the segmentation we use morphological method for extracting the foreground from the image. These are the pre-processing algorithm, and this after pre-processing we get this image silhouette image, and for with the help of PCA we reduce the features, and it provides the more efficient by decreasing the computational time and achieving the higher accuracy. These are the feature extraction. We divide the human body into two parts, upper parts and the lower part. That the upper part consists of head, neck, shoulder, and torso, and the lower part consists of hip, knees, ankle, and foot. Mm, these are the feature selection that we have taken the step size and the dimensions of human shell out image, and the joint angles. Angle we have covered taken head, neck, torso, and right hip and thighs, and left hip and thighs, and the lower right leg and the lower left leg. Coming on to the next slide is the skeletonization process. We use the critical point in the foreground for detecting the by using the gradient distance transform uh, point joint point estimation is done after the skeletonization process. This is the skeletonization process algorithm, and we have taken this data set in our work, and this is the performance matrix where we use with the help of confusion matrix. We define our result, that is accuracy, precision, recalls, and f1 score. After that we got this outcomes from the confusion matrix, where we have taken 86 subject for the training and 36 left for the testing, where we found 87 subject out of 88 predicted correct and one predicted wrong, while out of 36 one is wrongly predicted, that was not available in the database. These are our results. Mm, and this comparison we have done, so we got the if we combined PCA with SVM, we got the higher accuracy as compared to other technologies. And are the comparison with some other researches, and these are the conclusions. This study shows the different machine learning algorithms such as SVM, KNN, CNN, and the neural network and fuzzy set theory, discrete Fourier transform, etc. we use for human detection for their movement. The method we have proposed, the efficient method that outperform with the existing scheme in the terms of accuracy, and the accuracy of our scheme is observed as 98.38%. The method we proposed is efficient and easy to implement in the smart city for the person authentication. In future, we have planned for test our scheme in the various data set and on various performance metrics. Furthermore, we can implement this by using the different algorithm and for the and different conditions. And these are the references. Thank you.
Okay, Arindam. So which tool you have used for implementation purpose?
So we have used the Python. mm, mm,
Okay,
we have
so do you have such a data where the joint coordinates were given over there so that you can train it?
Sir, we have taken the image as an input, and from that we can extract that data by you with the help of a skeletonization process. We get that all. We extract that joints and all angles.
So which library function you have used for this purpose?
So for it, we have pre-processed that data.
No, but you required some tools that can identify which part of the body having joint.
So that was implementation part that was done by uh, mm, uh, another
Okay, no
author.
issue. Okay, no issue. Thank you. Thank you. Thank you.
Thank you, sir.
Thank you so much, Mr. Arindam. Our next
Thank
presentation
you.
is from Ms. VG Deepa. The paper title is A Comparative Study on Various Sharing Among Undergraduates in Pre-COVID-19 and COVID-19 Period Using Network Parameters.
Hello, madam. Can I hear me?
Yes, yes.
I'm audible.
Yes, you are
Okay.
audible.
Okay. Good morning, all. Myself, Deepa VG, Assistant Professor in the Department of Mathematics, Sri Krishna College, Guruvayur, Kerala, India. First of all, let me take this opportunity to thank the organizers of the international conference for giving me such a wonderful chance. Thank you. This is a joint work with my guide, Dr. Aparna Lakshman S. and my colleague, Dr. Srija VN. Let me share the screen, sir.
Ma'am, are you facing any issues?
Madam, ma'am, sorry, I couldn't share my screen. Just a minute, sir.
Please press green button, share screen.
It won't be visible, ma'am.
Bottom of your screen, Zoom screen.
Actually, I think so. You are live from mobile, so you are facing difficulties.
Just a minute, sir. There is. I lost the option for sharing my screen. I just want to see the.
You can do one thing, Deepa. You can try to log in with laptop. Otherwise, we can go ahead with the next presentation. So after that, we'll look into it for your presentation. Please.
Okay, sir.
Neelam, go ahead with the next presentation.
Yes, sir. Sure. Our next presentation. 5G open array infrastructure for sustainable communities.
Hello, am I audible?
Yes, yes, you
Hello.
are.
Okay, okay. And how about my screen? Is it visible?
Yes, yes. Totally.
Okay. Hello, all. I hope you're doing well and staying safe. This is Mushtaba Nayati, an international PhD scholar at Amrita Vishwa Vidyapeetham, Department of Sustainable Development. So I will be presenting our paper called Blockchain-Based Location Sharing in 5G Open RAN Infrastructure for Sustainable Communities in behalf of my other colleagues. So to break down the title, it stands on 4 different main pillars. And the first is the sustainable approach to connect the unconnected people in the rural areas. The second pillar is 5G Open RAN and dedicated coverage for community development, which focuses on sharing infrastructures and more energy efficient compact data centers, as well as ultra reliable connectivity to support advanced rural applications such as AR/VR based distance learning also emergency relief with drone networks and community kiosks for weather alerts and etc. The other main pillar is the blockchain technology, the distributed ledger technology, which offers decentralization to eliminate the cyber attack and clarity to a better auditing processes and security, as well as building a trust into the new systems. And the last pillar would be sharing the private data under the control of the user with the use of a specific framework that I will be explaining later on. So although people in the rural areas can benefit from a various range of services on the internet, such as precision farming, disaster support, and healthcare services, to elevate the quality of their life and to elevate their livelihoods. But the digital divide existing in those areas, preventing them from accessing to those services. And the main reason behind that digital divide is the low return on investment, which hinders the local mobile operators to go and cover those areas, or if they have the infrastructure in those areas, to upgrade those infrastructures to keep it to the latest updated systems to coverage more people. And to follow the SDG goals from United Nations, the United Nations, to be specific, the goal number 9, to bring connectivity to such areas, we have reasons to believe that the solution to this problem requires a tight cooperation between the stakeholders such as LCNs, government councils, NGOs, enterprises, and utility companies to share the infrastructures, the networking infrastructures with MNOs. Therefore, they might be able to cover the above mentioned areas and the people in there. So both 5G Open RAN and blockchain technologies, both are high potential technologies, but yet to be mature. Each of them are having specific benefits bringing to our life soon enough. The 5G brings ultra reliable and low latency connectivity, as well as massive machine type communication, enhanced mobile broadband. And on the other hand, the blockchain technology offers decentralization, which prevents the cyber attacks, security, it elevates the security and helps the auditing processes and helps us to benefit from smart contracts. So merging these two technologies makes the stakeholders capable of sharing their networking infrastructures with the other stakeholders in an automatic way and in a secure way to share it and get the payment instead. So the framework which has been proposed here, which is the result of this combination, brings the following achievements. The first is the secure data and fund transactions. It brings also the automated agreements using smart contracts, sharing private data, improve user experience, better coverage in the rural areas, and the trust business environment, which means the word trustless means the business parties don't need to trust the other party or even know the other party, because the smart contract lets them to will handle all the transactions and agreement and monitor the agreement terms, so there won't be any need to trust the other party. So you can imagine the life would be totally different in use of smart contracts. So the proposed framework will be utilizing a private blockchain running on a specifically designed new new consensus algorithm called proof of connection, which is a combination of proof of authority and proof of stake consensus algorithm. When a new node wants to connect to this framework, if the node the node might be a new MNO or a LCN or any other of those stakeholders that I mentioned earlier, they should be authorized before joining to the network. So right after that, they would be needing to stake a specific amount of digital assets as a guarantee for good behavior and not acting maliciously in the system to bring harm to the system. So the first part, which is being authenticated before joining to the network, is a proof of authority attribute. And the second part, which is to stake a specific amount of digital asset or money, would be a attribute from a proof of stake, which in this proof of consensus algorithm called proof of connection, we mixed both of them for a better performance. There will be two types of nodes in this distributed system and two types of different softwares also. Sorry.
Sorry for the interruption. So yeah, just please try to conclude it. We are just running out of time.
Yeah, okay. So the two types of node as full nodes and light nodes, as well as two types of software as the main software to be installed on network management system and decentralized application to be installed on user equipment and as well as a third-party server. So for data sharing, what will happen is the user will the user equipment will measure the low receive signal, receive power, and then the decentralized application installed on the equipment will initiate a technical evaluation of the networks around and will send the request, handover request to one of them. And finally, that specific visited network will create a smart contract with its home network for the handover process. And at the end, the data sharing process will happen after the user starts the a location requiring third-party service. And then the decentralized application and at the user equipment called Slice Connect, we call it Slice Connect, will automatically ask the MNO to share the user's location with the third party. In that time, the third party, the decentralized application at the third party will confirm whether it received the data or not. If it received, then it will let the smart contract know to release the digital asset to MNO's wallet. Otherwise, the digital asset would be going back to third parties' digital wallet. So to finish my presentation, I will go just a little bit deeper to the logic of the smart contract. At first, when it initiates, it will check the validity of digital signature from MNO and the third party in the both side of this contract. Then it will check the balance of third parties' digital wallet. If it had the enough balance in it, it will send the order to MNO to let it know to share, to encrypt and share the location from the user's location and send it to the third party. And in that moment, and it should be happening in a specific amount of time. And when it happened, the third party digital application will, decentralized application will acknowledge and say to the smart contract to release the money, release the digital asset. Otherwise, it will throw an error to let it know that it didn't happen. So the money which has been blocked from third party's digital wallet will be going back to its original place. Thank you for your patience and listening to me. I would be glad to answer your questions if you have any. Thank you so much.
Thank you, sir, for your nice presentation.
Thank you
And
so much.
I hope it is very useful and having a lot of opportunity to apply in coming days, like we are experiencing in India also.
Yes,
A lot of companies are offering, especially in metro nowadays, 5G. So
exactly.
just I was wondering to think about theoretically, it is really seems very good. So have you got any opportunity to implement it maybe in
Okay.
a simulation environment, maybe
Yeah.
like that?
Yes. Okay. So as you know, these two specific technologies, as the 5G and the blockchain, is slightly different in the implementation from the other new technologies because it takes a bit more time to design it and go through the logic phase of it, right? And the implementation side of it would be a little bit easier. So no, we didn't find a chance to implement it yet, but we don't have that much of distance to get it implemented.
Okay, thank you.
Yeah,
No issue.
thank you, sir.
I hope it would be very great, and you in future very soon you will get opportunity to implement all those things. And
Thank you so much, sir. Thank you so much.
Thank you so much. Our last presenter, Miss Deepa, is back and ready with the presentation. So, hello, Miss Deepa, you can start.
Okay, ma'am. Is it visible now, ma'am?
Not yet. Yes, yes, it is.
Okay, thank you, ma'am. Once again, I'm Deepa. I'm sorry for the inconvenience. Let me start.
please go ahead.
Okay. One of the best ways to analyze social, cultural, economical, and emotional intellectual components are by using the network parameters in social network analysis. Interpersonal network is a graph comprising of nodes and edges used to speak to social relations. SNA is the best way to examine social structures using graph hypothesis. It portrays organized structures as far as vertices such as individual actors inside the network and the edges, or link indicates the relationship or associations between them. My topic of presentation is a comparative study on variance sharing among undergraduates in pre-COVID-19 and COVID-19 period using network parameters. This is a joint work with my guide, Dr. Aparna Lakshmanan S. and Dr. Srija VN, my colleague. This is an outline of my presentation. COVID-19 is a staggering illness brought about by an as of late found coronavirus. This has totally changed the manner in which we approach the life, particularly in propensities, working environmental, public transportation framework, and not least the institutional education system. Institutional education system offered approach to online training framework. From the vast world of classroom, each student was confined to the internet. During teenage, a good friendship can profit you in lifting your self-esteem, urging you to live healthier or simply hoisting an amazing nature. It's interesting to see how these changes in educational system affects students' friendship and various sharing between them. It was in this context we decided to do a comparative study of a classroom network using social network analysis tools during the period of COVID-19 and its prior period. This is the objective of our study. We studied the effect of coronavirus disease among students in a classroom network. We tried to understand various sharing such as emotional, intellectual, information, and financial among 40 undergraduates in a classroom network during pre-COVID-19 and COVID-19 periods. Also, we examined the effect of gender, caste, locality, financial status, and intelligence quotient level in these shares. We considered a population of 40 teenage students in a classroom in Kerala for this social network study. A questionnaire is prepared and collected the data individually. Each individual is labeled as 1, 2, 3, etc. 40. The collected data contains the information of emotional sharing, intellectual sharing, information sharing, and financial sharing for each student I and whom they approached for in the period of pre-COVID-19 and COVID-19. This situation can be explained by the help of a directed graph G is equal to VE, where the vertex set V is the set of 40 students and UV is a directed edge in E if U approaches V. This is the resulting graphs we obtained by analyzing the factors. This is the intellectual sharing graph for COVID-19 period. This is the information sharing graph of pre-COVID-19 and COVID-19 period. And these two graphs indicates the emotion sharing between the 40 teenagers in this group. And this graph shows the financial sharing during the pre-COVID-19 and COVID-19 period. And this now let's look to some mathematical tools which are used to analyze these 8 graphs. First of them is reciprocity. The frequency of loop of length 2 is measured by the reciprocity, which tells you how likely it is that a node you point to also point. The fraction of reciprocated edge is called the reciprocity R. That is, in a directed network R, it is a proportion of the probability of vertices to be mutually linked. For a purely bidirectional network, the reciprocity must be 1, and for unidirectional network, this must be 0. Usually, the reciprocity lies in between 0 and 1 for social network for real situations. We can measure two types of reciprocity. One is arc and the other is diode reciprocity. Next, the other parameter is the geodesic distance. In a social network, the geodesic distance of two actors is the length in terms of number of ties of the shortest path between the corresponding actors. The average path length is another parameter. That's a concept in social network that is characterized as the normal number of steps along the shortest path for all possible pair of network vertices. The average or mean distance in a social network is defined as the average length of all shortest path between all pair of connected vertices. Average path length gives a feeling of how strong the relations in a community. Greater the average path length, numerous people in the social network don't straightforwardly have any acquaintance with one another. For in an undirected or strongly connected directed networks, average graph distance d bar is equal to summation u not equal to v degree of uv divided by n minus 1. N cardinality of v. And this average graph distance d bar must be less than or equal to n minus 1 by connected graphs. The average graph distance is a characteristic measure of compactness of the greatest distance between the pair of nodes is called the diameter of a graph. Generally, in a graph G is equal to VE, the diameter is the largest distance between two connected nodes. That is, D is the maximum of D of UV. If a graph has diameter, then there exists another measure also called radius. The reciprocity of a network is positively related to its density also. This is the results we obtained while analyzing the 8 graphs during these 2 periods. This table shows the intellectual sharing, financial sharing, emotional sharing, and information sharing in pre-COVID-19 periods. And this table shows the values of the parameters obtained during the period of COVID-19. This table shows the effect of gender, caste, locality, financial status, and intelligence level in these 4 sharings network. And finally, we reached the major observations. The intelligent network is strong during the COVID-19 period. Density of the information network and emotion network is almost same in both pre-COVID and COVID-19 period. The average graph distance of the financial network is considerably small when compared with the pre-COVID-19 period. Locality is the most influential factor during pre-COVID-19 period. Caste also plays an inevitable role in these sharings, whereas these two elements having any role during the COVID-19 period. Gender, financial status, and IQ level does not affect the sharing network both of these periods. This is the major references we used to prepare this paper. Thank you.
Thank you,
Sir.
Ms. Deepa. I have just one simple question. So, by applying the
Okay,
various
sir.
technique, you have observed some data and results. So, how you have validated your observation and results are good and accurate? So that your model, the government or any other organization can use for the future prediction.
We collected the data directly from the students and analyzed using social network analysis tools, sir.
So that
And
is
this
the
is the
result.
mathematical tools.
Yeah, that is the tool you have used. You have used to
This is
get
the
the
major
result.
observations we obtained, sir.
My
This is the
question is
major
that whatever the
observations.
result,
We
whatever
are
the result.
happy to
Yes, my question is that.
this is a result.
Yeah. My question is that
Okay.
whatever your results are there, why somebody will believe on that? That is called validation. How you have validated the results?
Actually, this is a data study, sir. This is not based on a particular model. We collected the data and analyzed using mathematical tools, and we obtained in these observations.
Okay.
We are very happy to present that the intellectual sharing network is much stronger during this period. That's a positive.
Thank you.
We found it is very positive.
Thank you,
Okay, thank you,
Deepaji.
sir.
Thank you.
Thank you, sir.
Thank you so much, Ms. Deepa. Our last presentation of this session is from Mr. Gaurav Garg. The paper title is RP Android malware detection using ranked permissions and network traffic.
Okay, so hi everyone. Hello, am I audible?
Yes, please go ahead.
Yes.
Okay, so the title of our research paper is RP Android, which is a amalgamation of rank permissions and network traffic that we have used in the Android malware detection. So myself, Gaurav Garg, I'm a student at Delhi Technological University from Delhi, and the co-authors are Ashutosh Madan and Professor Anshul Arora, who are from the same university. So let's move on to the introduction. Um, So, okay. So as of the data from 2019, there are 2.46 million applications on Google Play Store and 1.96 million applications on iOS Store, which shows the popularity of Android. But as we all know, all applications in the market are not safe. So the seriousness of malware attacks can be depicted on the fact that around 25 million Android smartphones were infected with the malware as of 2019. And keeping these threats in mind, we aim to develop a hybrid Android malware detector based on rank permissions and network traffic. So hybrid Android malware detector is a combination of static detection and dynamic detection. So in static detection, we have permissions, and in dynamic detection, we have network traffic. So let's move on to permissions. Android provides permissions access as one of the security control mechanism that provides the restrictions on certain operations an app can perform. For example, on the Google Play Store, when we download an application or install it, then they ask for certain permissions like camera or internet or read your storage. So these are the app permissions that are used to restrict some operations. And network traffic refers to the data moving across a network at any given time. So network traffic consists of packets, small packets that the data is broken into. So it is the smallest fundamental unit of data passed along a network. And we have used some properties of network traffic to also detection for malware detection. So like the properties, for example, like maximum packet size, what is the size of packet, or the average packet size, or packets received per second. So these are the some network traffic features which were used. And let's move on to the methodology. So first we have the raw data from APK files, like we have Android data from Google Play Store, Android APK files, and some malware APK files. So to extract the permissions, first we extracted the manifest files. Those manifest file contains permissions and some properties about the applications. And then we extracted the permissions from them. Then we extracted then we ranked the permissions based upon their frequency in normal and malware data set. So we have two differentiated data set. Then we rank the permissions based upon their frequency. The ranking varies from -1 to 1. So we obtained two different permission ranking, one for frequently occurring permissions in malware and other for frequently occurring permissions in normal applications. We can we created those permission rankings on the basis of sorting the ranking. So like ranking is the formula for like difference in relative frequencies in malware and normal applications. So if a rank is -1, then it shows that it is very clean permission. It is only present in malware, normal applications and not in malware. And if a rank is positive, then it means it is very dangerous permission. Then we applied the several support thresholds to eliminate the lower rank permissions. If an application, if a permission is lower rank, that means it is present in very low application. So it is not very important. So we applied several thresholds on the basis and discarded them. Then we collected the network traffic features using T-packet capture with each malware application. So we installed the T-packet capture and the application, and we run those applications for some time, and we collected the network traffic features. Then we merged the top rank permissions with the ranked network traffic features to create a hybrid feature vector. And the hybrid feature vector was used in the machine learning algorithms to detect malware. So moving on, here is the figure for the model that we used. Here are different applications. Then we extracted them to create a feature matrix. Here the column represents the permission and the application are the rows. Then we rank those features to create two rankings, and then we use the threshold, and then we use malware algorithms to create the model, and then we use testing for detection the malware applications. So here in the testing phase, we got two tables. Table 1 shows traffic features used in experiments. So as I said, there are we use 9 prominent features of network traffic. First is average packet size, ratio of incoming to outgoing bytes, packets sent per second, packets received per second, maximum packet size, and so on. And here are the top 15 permissions in ascending and descending order. As I said, the negative rank shows that it is a very clean permission, and the positive rank shows that it is very dangerous permission based on the formula. So like here are some examples like wake log, get accounts, read external storage. They have decreasing ranking. So like so these are very clean permissions if they are in they are only in normal applications. And if a read phone state, read SMS, send SMS are very dangerous permission. If an application is asking for send SMS, then it is maybe sending some very private data from your phone. So moving on to the results, first we did static detection and dynamic detection separately. So when we use only permissions as the features in the malware detection model, we got these accuracies. So at threshold of 0%, when we use all the permissions, then we got highest accuracy at random forest with 91%, 91.34%, and so on. And when we use dynamic detection model, that the network traffic features, the 9 network traffic features, then we use the 3 models, naive Bayes, random forest, and SVM. We got these accuracy like 94.76% at both random forest and SVM is the highest. Then we combine those permissions and network traffic features, and this is the hybrid detection results. So at 0% threshold, we got the accuracy of 95.96% with SVM model, which is the highest with 0% threshold. And as we move on to the 5%, 10%, we are decreasing the features. So as we can see, on decreasing the features, we get somewhat low accuracy like 94%, 88%, 83%, and so on.
Dear Gaurav, what is the threshold here?
Threshold is the number of the number of applications the permission is in. For example, if I am seeing there is a 5% threshold, so I am counting that the permission is at least in 5% of the applications.
Okay.
Okay, so like if the permission is present in very much applications, like about 50% application, that is a 50% threshold. And if I'm considering even one occurrence of the permission in application, that will come in 0% threshold.
Okay. Okay. Okay.
So conclusion was only this, like we use the permissions rank
Okay, very good,
permissions.
Gaurav. Just I want to have a discussion about you have applied various machine learning algorithms in the given domain. It very nice to see at your age you are doing all those things. So I have just one eager to know you have applied many algorithms. That's very good. Have you gone through the working the structure of the algorithm, how they work, some mathematics behind that one? Have you gone through all those things?
Yes, sir. In the university, we have a course for machine learning where we have gone through all of the mathematics, like name base uses likelihood features, random forest is a like combination of different decision trees, and like what does SVM do, create different planes and all that.
So, like a random forest, can you share some pruning techniques? It create a lot of tree. Tree maybe are very bigger in size. How to prune it?
We actually didn't implement the random forest, sir. Like we used the only inbuilt random forest
Let's
because
agree. If you are using inbuilt function, means already implemented.
yes, sir.
So already implemented means everything is there. By default, settings are there. Means the pruning this techniques by default it is using. So I think you must go through all those things in detail. That will help you a lot in your career to fight out in the internship programs for getting a job, because the company asks in detail the working
Yes,
of the
sir.
algorithms.
Yes, sir. I
Yeah,
agree with you.
yeah. Thank you, thank you.
Okay. So, in acknowledgement, we would like to thank the researchers of Genome, Drebin, and Kudus projects for providing us the malware dataset for experiments. Like it was a very big help from these projects to get the malware applications because we cannot get them anywhere else.
Thank you, thank you.
Thank you.
Our organization are done. So, shall we go ahead with our closing remarks? I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. So kindly cooperate with the team of WS4 2021. I also thank our session chair, Dr. Vivek Tiwari, for chairing the session. A token of appreciation to the chair on behalf of Team Valdes for 2021 and the Global Knowledge Research Foundation. Thank you so much, sir, for your valuable
Thank you, thank you.
presence.
Thank you for your kind
Also,
invitation.
yeah, thank you, sir.
Please share
Also, I request you all to,
yeah,
yes,
share
sir.
this certificate to my mail ID possible.
Yes, sir, sure, it will be.
Sure.
Also, I request you all to on the camera for a quick snapshot of the virtual conference. I request rest of the authors, if possible, to on the camera. Great. Thank you so much. Thank you so much,
Thank
everyone.
you. Thank you. Have a good day. Thank you. Take care.
Thank you. Stay safe. Take care.